Okay, we are supposed to be live right now. I think so. I think we're live. I can see the chat here and OBS. So we today another recreational coding session. This will be a short one. Now what I want to do is count down, live countdown. Can I just do what is this? No, why is it so back to count? What? Okay. Hours. 1 hour. We are going to set a countdown to 1 hour because I always forget to have a pause. So we're going to have a break after 1 hour. Let me just restart this. Okay. So we are going to be a little bit today having fun with inter-process communication. This is not, again, this is not my field, so I will be learning some stuff as well. Okay. Okay. So let's just set that and start it out. All right. Okay. I've made here just a simple project with a main CPP that will build using using CMake lists, but I don't think we will need. We could have built it using just the compiler directly, but maybe this will be cleaner for future. What I want to start with is I want to open up Chrome, and what I want to start is so shared memory. So we will be doing this on Windows, so there should be some there is this what I hear, like Linux is very much easier to work with, because in Linux you have you can like see the memory of all of these processes very easily, but Windows is quite a So what I wanted to show you, there was something I tried a bit some time ago, and what is this? Like, there was gists, right? Gists, is that how you? So today's idea, IPython shell test. What was this? This was through pipes, as far as I remember. This was like having some Python terminal and then piping, like having a process, having a C++ process that will create this Python process, right? And then it will create some handles for std out, std in, and will pipe some commands to the Python process, and then we'll read out, and then we'll close the handles. So that was some stress testing of the IPython shell interpreter. But we don't kind of want that, because pipes are slow, and piping through a pipe, like, it means that you are transferring the data. What I'm thinking of is, can we in Windows create like the same thing we have in Linux, like shared memory, where like you can mmap some memory, and then you could just one process could just you could just write to that memory, and the other process could just read from that memory. And since like it's in RAM, you could just do that, and you don't need to transfer to disk anything. Yes, and with pipes I think you don't transfer with disk, but I'm not sure. Create a pipe function. But another thing is that what I would like to do is I would like to have a Python process running a subchild process. So I would like to have this. I would like to have a Python process running some machine learning things. So some like running PyTorch. Okay, this is running on CUDA, but let's just for a moment imagine that you are logging in, you're saving some tensors to the memory, to RAM. And what I want is like, I want a C++ executable to read these tensors from RAM and visualize them somehow in real time. And the Python project could be just a sub process of this child process of this. There are some things like that, like you can create like a sub. It doesn't have to be a sub process. I'm not sure how this works. So like pipes, I don't quite know how fast pipes are. That's the whole. I will just I forgot to record. I don't know how fast pipes are. And create pipes creates a pipe, assigning the specified pipe size to storage buffer. Creates also handles uses read from and write to buffer sequential calls read file and write file. To create the pipe, a process uses the read handle encode and read file returns. Yeah, so like you're still piping, but you're piping through some buffers, and I don't want that. I want directly so I want like create file. There was a create file Windows API. Create file and creates a file or IO device. The most common file stream, physical volume, console, buffer, tape, drive. And okay, this is create file A. Is there create file W? Or what is the? Is that just the? Okay, well, yeah. So I want like shared, something shared mode. So there are a couple of arguments here. One, there is like file name, desired access, the request access to the device, which can be summarized as read, write both or 0 to indicate neither. The most commonly are generic read, generic write. Okay, and then there's the DB share mode, the request sharing mode to the device, which can be read. Okay, for access to the attributes affect this flag. If the parameter is 0, okay, we'll have to read about all of this. You cannot request a sharing mode that conflicts with the access mode that's specified in an existing request that has an open handle. Create file would fail and get last error function. Okay, get last error function will use that, of course. LP security security attributes are just security attributes. There's creation descriptor, an action to take. Yeah, if something like create new or open always, open existing file. DB flags and attributes. Yeah, but the C++ project, the C++ thing wouldn't need to create a file, but actually like the Python would need to create a file. So there's on Linux there's this okay, mmap, there's mmap, like maybe just looking for mmap Python memory mapped file support. This module does not work or is not available. Okay, on WebAssembly, memory mapped file object behaves like both byte array and file objects. You can use memory map most places byte array. So memory map is created by map constructor, which is different on Unix and on Windows. In either case, provide a file descriptor for a file to open. Memory mapping for a writable file. So can we get changed in 3.7 access? Okay, so we will have to, yeah, we will have to see about like memory map. So import memory map, you open some file, you write Python, you open this file, and yeah, this is the simple example file, and this is like memory mapped. Read, what is this flags? Read plus bytes. It's a byte file, but this read plus memory map the file. 0 means the whole file. You are okay, you are redlining, which prints p. Yeah, so yeah, so this is like you're creating here some file, and then you're like reading from the same file. That's why it's like this. But of course I want this memory map to be like in the memory itself, not in the in this in on the disk, you know, because this is different. Simple examples. Yeah, so we have to see what are the flags here, but the flags are map shared. Protection right, protection read, access default. Okay, we'll have to learn about all of these things because we want to understand what happens inside, but there is this mmap. So this would be interesting to see. Okay, so let's go to this here. Let's here make a new folder. It's called Python. Let's go and let's see, not mmap, how should I, child. Okay, so let me get an example thingy here. So an example, open f open. So yeah, import mmap, and then you do like open is not from mmap, right? Open is just opening stuff, but is it from, this is from mmap? No, this is from the stdlib. No, of course, this is a file. You're opening the file and then you're memory mapping this file. What was this? I forgot how it was called. Integer file descriptor. Yeah, file descriptor. You're mapping the file descriptor to a memory, and then you're reading from the memory, and then you're doing this. So what if I don't? What if I just do mmap, and what if I just see here? Okay, Windows has this file descriptor, which is an integer, length and offset. Okay, so but we don't know the file descriptor, right? We have to create, what do you have other things here? You have only mmap. Okay, so let's search create memory mapped file Python. Yeah, so how to use memory map in Python Linux. The whole thing is that, okay, so we don't want to create a file as file. We want just to so there is a module which like works through the already through mmap probably. FD, the file descriptor, is you're opening a temporary file here. This only works on Linux. On Windows it should not supposed to work. Okay, so there is this interprocessor communication. This processor is an example of how to do fast interprocessing using memory map file in Python. It is designed to be minimal learning material. It shows you how to send an image from one Python to another process in around 3 to 4 milliseconds. 3 to 4 milliseconds for this kind of an image, but what is the so it depends like on the size of the image. Is it a raw? Is it what is it here? But I would guess it's some kind of raw image. So server, yeah, but all this should only work on mmap is like -1. You're mapping and a random tag name. You are mapping to -1 in n. N is the dimension of this image, and then you're seeking at 0. You're reading it. Yeah, okay, so I understand this, but this is from the client side. From the just using a random tag name. Does that work on Windows? That's the problem, because on Linux like you can do stuff, but on Windows it's file number, so providing -1 to pass to map anonymous memory past -1 on both versions. So -1, then you're passing the length of something. So this is like, okay, so let's have some array of like I don't know, random numbers. The length is the size in bytes probably, right? So maps length bytes. Okay, the size in bytes is kind of hard here to, like, image size here. What he's providing is, yes, this is bytes, but this here is ×4 if we are actually doing this. But this is a Python object which cannot be mapped like that immediately, right? You have to convert to bytes. And is there to, and there is so yeah, so if it's a string, right? So let's say a string, convert string to bytes in Python. You have encoding UTF-8 str encode my string. Okay. So okay, so hello from hello my child, hello from my child, and then you are doing str, and then str.encode a UTF-8 is the encoding, so that's cool. Bytes, and you here probably this is, can I say length of bytes? Is bytes an object that actually has a length? Yeah, it does. Okay, cool. So I can say this, and then the tag name is like, okay, YouTube. Oh no. So I'm getting this, and what am I doing here essentially? Is essentially getting to bytes, mmseek, write the buffer. Oh, so here is just, yeah, you have to write it and then flush it. So mmseek 0 is like resetting on the zeroth. I'm writing the bytes and I'm flushing it, and then I will be waiting for like an input of the user, right? So I have that thing here. Cool. Can I check what does write give? Write gives an integer. Can I check if it's been like successful, right? That's the thing. Okay, so let's go write bytes, never less than write the bytes in memory on the current, return the number of never less than length of bytes, value never less than length of bytes, since if the write fails, the value, the file position is updated to a point after the bytes were written. If the mmap was created access to read, then writing it will raise a type error. Yeah, access. I have to give an access here. And what is the default access? Why is this so? The document, where is the default document for mmap? Okay, for mmap Unix version, I don't care about Unix version. A Windows version, this is what I care. Access default, access allocation granularity. Okay, this is like if I want some offset from the map, that from the page. But access, what is access default, you know? Like how can I why I'm not given anything here on access read, access copy? Can I see access default? What is this? mmap? Is it in the mmap access default? Access read, access copy, access default is what? Why is this just yeah, this is types. This is just types, right? stdlib mmap. What is stdlib? Okay, let's assume that access default is okay. But okay, so we are going to be let's go and let's say, okay, like this, Python py child. Okay, cool. But YouTube, okay, now I want to say that how do I access this? Okay, from another Python file I can do this, right? But how do I do it from C++, you know? So accessing mapped memory from C++ were these functions. Here get file open. Yeah, there should be some function where you open the file. So when you create a file, you want to Windows API open file, open file, file name, name of the file, open Windows API open memory mapped file. Open file mapping A. Okay, desired access LP name. This is what we need. The name can have global or local prefix or open in a global or local session. Return a value. Okay, so let's go in C++ now. And let's try to open file mapping. So let's try to open a file mapping. Which is this? This is WinBase. Include WinBase. Will it compile? Just cmake. Do I need to what do I need to do? Do I need to link something? I have to link something, right? Well, missing. Is it just WinBase? Do I need to import something else? Okay, let's see. Create file mapping. How do you do this? What do I need to link for? Just include windows.h. Yeah, okay. So this was it, windows.h. And now let's open this. Let's try this. Open file mapping. A is enough for us, and the dword access now. Now the thing is, we don't. What is this dword access? A list of values. Access rights. All access includes all access to the map. Includes just the read access. I need just the read access. Can I do this and inherit what is this? Inherit handle. If the parameter is true, a process created by the create process function can inherit the handle. Otherwise, the handle cannot be inherited. Oh, okay. So, but this is if the process function. Let's say just true for this. And this is like the name, and for us it's like YouTube. And now we have some handle. And since this is since this is the handle of the mapping, we have to check if the handle is good. If the function fails, it returns value of null. So if handle is null, so let's not name it this the old convention. Let's just do this. We are going to return 0 and just see out couldn't open the memory mapped file. Okay, cool. Now that we have this cmake build, and this is in debug what is this? Yeah, it should open up the this. But what if I now have this other process, and I have a batch terminal, and I say Python, and I map this process, and can now open? Yeah, now it can open. You see? Now it can read it. That's promising. That's pretty cool. That's pretty cool. Pretty cool. Now it can open. So let's just print out here. Okay, so let's just say, okay, the file has been opened. Let's, instead of YouTube, just for this, let's say love, because these processes love each other. And okay, let's just print I have opened my heart. Okay, cool. Yeah, let's do, okay. Okay, the file has been opened, and now if I go here and I go cmake build, and I go this, the file has been opened. Okay, cool. Now, since the file has been opened, we can read it, and there is probably a function to, I mean, there of course is a function to read the file. I just don't know how it is called. Since create file was this, there has to be read file something. Read file Windows, and you probably give a handle. Yes, you gave a handle to the file. You give an output buffer where you read it. You give the number of bytes to read. You give, what is this now? Number of bytes read. And is it overlap? This is like overlapping files, overlapped pipes. If the pipes are overlapped, this can, like, you could just have you could have multiple pipes on the same handle or something like that. I'm not sure about that, but there is a difference between unoverlapped and overlapped pipes. Yeah, so we're not doing that, but since we have this memory, hello from my child, hello from my sweetheart, that's cool. Okay, so cool. Couldn't open memory mapped file, and now I want here read file, and I give a handle. I need to give a pointer to a buffer where I cannot do. I can do for now I can do this. Bytes to read is like max buffer, so let's just do const int buffer size 124 buffer size. But since, you know what, since you're reading the file, you know, to some kind of buffer, you could make this buffer pretty big, I would guess. But also, like, this reading of a file, like, it calls this Windows API, which calls like some system calls, right? And it's not like in, like, back in the day, like any process could read files like the memory from any other process. And like physical, there wasn't like virtual and physical memory, right? So like you could just go, like, you know where that position, where that memory address is, and then you go to that memory address and you just take the pointer out of this memory address, like the pointer to that memory address. And what you're like doing is like you're completely reading from the memory of another processor just because you have the pointer to that memory. And you don't need to call system calls to do anything, right? You're just reading that memory right there and then. And it was so simpler, so fucking simpler. Now you have to call a read file, which you have to provide a fucking buffer. And this, if this buffer is like, it's like very small, you're gonna have latency because you're gonna like push to this buffer and then like push it somewhere. So you have to provide a big enough buffer, or like expect like some exact buffer, and then do all this kind of stuff. Number of bytes to read. So can I just say buffer size? And since this is like number of bytes read, is this number of bytes read? But LPD word is like what? Or you're providing a null pointer and then you're saying like how many bytes you've read? Is that how it works? And LP overlapped. What is LP over? Is it like it's an optional otherwise can be null? Can we just say null? And like, okay, bytes is like what is bytes now? LPD, what kind of word is that? Is that 64 bit? Yeah, it's a 60. It's a 32 bit. Yeah, it's 32. It's again 32 bit, but it's unsigned. Is it a UNT 32? Okay. So then you get some boolean, which is like success. Why is that not matching the 32-bit unsigned long? Yeah, it's 64-bit. Yeah, this is like the documentation. Wait, who lied that the word is 32-bit? Why, when this is like LPD word unsigned long? Yeah, it's 32. Oh, wait, what? Wait, it's 32. It doesn't like being 32-bit. Unsigned long. Well, unsigned long is how, like, it depends on it depends on this depends on the this is not exactly 32-bit, like it could be 64 depending on the architecture. Okay, whatever. Oh, what the? Okay, so if it's not success, then we can say couldn't read memory. Couldn't read memory and return 0. And if it is success, since we have already like in the buffer things, we can just see out the buffer. Oh, is it yeah, is this string null terminated? Okay, just for the sake of this. Okay, so let's say that here we exit, and let's say print length bytes. And since this is UTF-8 and all of these are 17 bytes, so 1 2 3 4 5 6 7 8 17, so it's not null terminated. So there's nothing null terminated here, but it could be that memory that, like, if you were writing the bytes, that it could be that you null. What about now? And now it's null terminated, you know, but it should be 18, right? Or did I count wrong? Is it possible that I counted wrong? No, yeah, so it's just, but it's not null terminated. You have to null terminate this. Okay, let's do this, and let's do make build this. Unsigned and signed mismatch. Oh yeah, of course, this is this should be that. Yeah, you see, v4, like warnings, if you have like warnings, it like tells you, I mean, it tells you a lot of things. Warnings tell you a lot of things, so it's not just couldn't read memory. Now I'm thinking about, like, do you have permissions to read that memory? Or do you, like, yeah, what is the bool, yeah, no, what is the bool, what does it return, this read memory thingy? Maybe it returns something else. Return if the successive return is non-zero, which is true. If the function fails or it's completely asynchronously, the return value is 0. To get last error function, and then on the get last error function, it like provides it gets an error. So you can just do get last error, auto error, and you can just do that, error code, six. So what is error code 6? Error code 6 read file. Async calls to error code, it means invalid file. Is overlapped structure, which you don't initialize properly. Any unused member of this structure. Oh, overlapped file. Oh, do you have to give the overlap structure regardless the official thingy? A pointer to overlap structure is required if the H file parameter was opened using the file flag overlap, right? Otherwise it can be null. No, this is not open using the H file parameter. Yeah, the H file parameter should not, yeah, it's mapped, it's using file mapping, but I don't know, is that overlapped or not? Okay, so there's this thing, invalid handle of val, get error IO pending. What is the error here, you know, like what is this error code 6, you know? What does it error code mean? File handle not valid. Not valid file handle? Oh, can you maybe is it like read file and then like map, like read file map, file Windows file mapping? Maybe it just doesn't using both read file and mapping. Map view of file. So there's another function. Map view of file requires you telling where the view is mapped relative to the using create is and it's mapping view using map view. The start of the file address is held at the start pointer. Read file only move on disk file pointers. So wait, how are you supposed to read that? Creating, sharing files and memory, reading and writing from a file view. So do you need a file view? Reading and okay, this is a little bit more complicated than I thought. Okay, let's see. Sharing, file mapping can be used to share files or memory between two or more processes. To share memory, file or memory, all processes must use the same name of the handle, same mapping object. To share a file, the first process creates by using create file function. Next, it creates a file mapping object by using create file mapping function. Specifying the file handle of the mapped object. So we're here specifying the we're creating a new file there from the Python, and then the names of the events or file names shared in the common namespace. Therefore, the file mapping and open file mapping functions fail if there's create file map. Yeah, the create file mapping is here. Open file mapping function here. Fail if they specify a name that is used in the to share memory that is not associated with the file. A process must use create file, specify invalid handle value. This is what we are specifying here, -1. This is the invalid handle value. I guess it's -1 as well there. Probably we can just see here. A long pointer -1. So this is like max -1. Yeah, but essentially it's -1. Yeah, because it's like it reverts from the, I think, I'm not sure. Specifying invalid handle as per existing file. Okay, this is way for the other process to obtain obtain a handle of the file mapping process is to create the first process that's using file mapping, open file mapping object name. This is referred to the named shared memory. If the file mapping object does not have a name, the process must obtain the handle through an interface duplication. Okay. Processes that share memory or memory must create file views by using map view of file or map view file externally. This is probably like the some asynchronous function or whatever. Maps view into the address space of a calling process. Okay, all of these are inputs here. File mapping object, desired access, file offset high, file offset low, number of bytes to map. A handle to a file mapping object, the create file mapping, return this handle. Oh, this is the handle. Okay, desired access is this, whatever. this is high order D word where begins. Okay, if the function succeeds, the return value of the return value is the starting address of the mapped view. Oh, so you're mapping a view into your own process here, and that's the return value, the start. Yeah, okay, cool, nice. So you're not actually needing to do that shite. You want to do the following. You call this function map view of file, and you give the handle. You give the desired access, and the desired access is what? File map read. File map read. And you write file map read file bitwise, or yeah, the desired access file offset file div file offset low div file offset high. The allow order of the file offset to begin the combination. Can we just do like null on this? And then number of bytes to map is like the number of bytes to map in file view. All bytes must be within the maximum size specified by the create mapping. If the parameter is 0, the mapping extends to the specified offset to the. So can we just say like null and like 0 and like get this pointer? What is this? A void point? LP void, where like the view is created. So essentially, we can just do. Can we do this? Is that even possible? The file has been contents of the file. Can we do that? Is that even that simple? Oh my! Oh my! That's that simple? Oh sh! Oh! Oh! That's amazing! That's fucking amazing! Look at this! Look at this! I can open a file from this process. From this process, I can map a file onto the memory view of this process, and I can read it like this. Amazing! Amazing! That's simple. That fucking simple. So imagine like the next the next thing is like, imagine like you have tensor here, and you fucking read that tensor here, and you visualize, and you know what I want to do? I want to do that, but on the GPU. I want to have afterwards, I want to have a file mapping on the GPU itself. From one of the process, I map I share the memory, and like I access from the other of the process the same memory. And what we can do is we can get the pointer to that memory on the GPU and give it as a buffer on the C++ side, or on the Rust, or whatever side we will be using. And then like this Python project does some AI calculations, whatever, and it's like saves some tensors, right? And it creates these like shared maps, shared pages. This the C++ or Rust side or whatever side we'll be using access these pointers, but on the GPU side, right? It puts them as a buffer. It just says, okay, this is a buffer, and it gives it to a shader, and the shader creates visualizations directly from memory. Sick. We can do shit. We can do really sick stuff here. Like, if it's that simple for Windows to just memory map shit, okay, in the GPU it won't be that simple because like GPUs have like some other stuff, but like even on the CPU side, it's amazingly simple with these like named handles. Like you can just have a fucking name handle and this is it. Okay, cool. Okay. Should we make a pause? What I want to do is like I want to just go and create a repository there. Let's see how much to. Oh, we have 5 minutes. Okay, cool. Maybe yeah, GitHub. Okay, so let's make a repository. Let's name it shared should we what should it be named? Okay, this is like CPP Python, right? Shared between CPP and Python. What is this? What is bare metal? Not bare metals. Like how it's called? What is called this? Foundation. Foundation synonyms. Foundation basis starting point. Yeah, something like that. Core. No, not core. Basis starting point. I don't know. It's the point of departure. What? Why do you have this heart? I don't know. Starting example of shared memory between memory between C++ and Python. Between C++ and Python on Windows. So we are actually just Windows, yeah. Because I don't even have. I mean, I have a subsystem for Linux, but examples of shared memory, CPP, and Python. And I can just remote add this stuff here. Can I just do this? Why would you copy this? Not a Git repository or any of the Git. What I Git init? Git remote add. Okay, so all of these files here that we are building, they don't kind of matter because this is like only like C make garbage. C git ignore. We can do okay, debug, release. We ignore that. We ignore CMake files. We ignored shared memory dot that this is dot there. Can I just say that I ignored debug on like on this level. How do I say that I ignore debug here? Yeah, this ignores the debug here as well. I don't care. Shared memory love dir. I ignore that. x64. I ignore that as well. Do I need a cmake cache? I think, well, you can delete all of this and cmake will create all of these again. But do I delete them? Yeah, I mean, let's I don't know, because like zero checks projects, and yeah, these have like include files, and I don't want that. I okay, I will just do this. What's xproch? Can I do this? And then I will do ignore the solution as well, and cmake install. All of these like .cmake should be ignored as well. Yeah, this is exactly enough to work. You can build this here thingy, and you can build this child thingy to do that. Okay, cool. So if I go this, shouldn't open the file, to open memory maps file. Now that I have this, yeah, I want to use fork because fork is better. Let's open up repository. Whoa, what is this? Let's open up the repository. GitHub shared. Select this folder. Okay. Simple example of sharing memory between C++ and Python. And create tracking reference. Okay. And now we go this here, shared CPP and Python. Yeah, okay. We forgot to add the readme file, so I'm gonna do that. And maybe just like, yeah, for today it's good. For today I'm just going to close the stream, but maybe tomorrow or the other a day later we'll do some even like nicer things, and maybe go back and like and code some cool stuff as well. Okay, so shared memory and love between C++ and Python. A simple example showcasing how you can make you can map you can share memory pages directly from Python and read the contents directly in C++. In the future we will be yeah, so I'm not gonna I don't fucking know. Okay. All right, cool. So I think that was a nice thing. We have we can do we can do so much more now that we have this. Now that we have this, we can finish our FF flip, or just like work on the FF flip, and then like try to visualize stuff that are in the FF flip. Try to visualize stuff again here on the C++ side, or and maybe we will be playing with maybe some Electron or some Tauri, so something like that. Yeah, cool. So thank you for watching, and I will see you in a couple of days.